The art of computer vision, teaching machines to see and understand the world. Hey there, and welcome back to the channel. In this video, we will be talking about the art of computer vision. But before we start, make sure to give us a thumbs up and subscribe to this channel. The first thing we will be looking at here is what computer vision is. In order for computers and other systems to act or make recommendations based on visual inputs like digital photos, movies, and other media, the field of artificial intelligence, AI, known as computer vision, was developed. Computer vision complements artificial intelligence by giving machines the ability to see, observe, and understand. Similar to human vision, computer vision has its limitations, especially when compared to the human starting point. The human visual system has had a lifetime to learn how to distinguish between things, judge their distance, detect motion, and spot inconsistencies in an image. Using cameras, data, and algorithms in place of retinas, optic nerves, and visual cortex, computer vision educates robots to carry out these tasks in a significantly shorter amount of time. Because it can analyze thousands of products or processes per minute, a system trained to inspect products or watch a production asset can quickly outpace human capabilities. Computer vision is the study of the algorithms and theories underpinning computer programs that analyze images for meaning. Video sequences, images captured by several cameras, or three-dimensional information from a medical scanner are just a few examples of the various formats that picture data can take. Computer vision aims to apply its theoretical frameworks and model designs to the development of practical computer vision systems. How does computer vision work? Computer vision works in 3 steps, and I will be talking about each of these steps. 1. Acquiring an image quantity. Massive datasets of images, such as those captured in movies or rendered in 3D, are required to train the algorithm. These features make up a good dataset. Quality. Data in large quantities is usually preferable. As far as machine learning models are concerned, there can never be too many images. Variance. Image resolution should be good enough to ensure clarity. Human-made opacities, such as truncation, are also unacceptable. Cars encompass a wide range of vehicles, from motorbikes to sedans to minivans to SUVs to trucks. There must be numerous iterations of the target object. Density. This density requirement means that certain pictures will have to be accurate representations of things like traffic and other vehicles. 2. Processing the image. The algorithms now look at the data. Because of algorithms, machines can now teach themselves to recognize individual faces. Therefore, the algorithms deconstruct images into pixels, identify sharp edges and elementary shapes, and iteratively test their hypotheses, assuming the machine has already been trained. The same holds true for videos, which the machine may interpret as a sequence of still images. 3. Understanding the image algorithms, then process the information in order to complete a computer vision task like picture recognition. Adjustable parameters allow for the output to be a label describing the contents of the input image. How long does it take to decipher an image? With the help of high-end processors and supporting hardware, the procedure may now be completed in minutes, if not seconds, rather than weeks. The precise duration is reliant on the input complexity and the duty at hand. If you aren't starting from scratch, you could get results in as little as 15 minutes. Naturally, the time required to train a model to decode images using a large database will increase. Applications of computer vision. Image classification. In order for a computer to categorize unlabeled photos into discrete categories, it must first learn from a training dataset of labeled images. It ultimately picks up on how each mandatory class should look. Semantic segmentation. To do this, photos are segmented so that individual parts may be analyzed and categorized. For instance, a computer will not only identify an object, but also define its confines. Video motion analysis. Motion can be identified by computer vision systems by locating the locations at which an object is moving, following its path over time, clustering locations that all belong to the same object in the scene, or determining the magnitude and direction of motion. Object detection. In contrast to the classification, this process assigns labels to a large number of items rather than a few key ones. In the case of car detection, for instance, the computer will locate and extract the bounding boxes of all automobiles present in an image. If you have questions or would like to share your opinion, You can drop them in the comment section below. Make sure to give this video a like and subscribe to this video.